Hello, our beautiful audience. Welcome again to yet another interesting discussion. While looking at calculus, this is differential calculus. We're looking at using the first principle, and I was taught to show that the derivative of sin x is indeed equal to cos x. All right, let's get started. So now we know that dy dx, this is a notation for a derivative, can still be expressed as f prime of x. Okay. And also y can also still be written, which is sin x is the same as f prime of x, f of x, which is equal to sin x. Okay, now from first principle, which is f prime of x, the same as dy dx, is simply a method which is in the form limit as h approaches 0, h a variable, of f of x plus h. Mean that to x you add h, then you say minus f of x, then divide everything by h. Okay, so now here our function f of x is equal to sin x, so which will therefore mean that f of x plus h here, this is also important, we need to find this, will simply be equal to wherever there's x in the original function, you simply substitute with x plus h. So this will give us sine open parenthesis x plus h. Alright, now we'll continue with our solution. So this will be our derivative, which is f prime of x, will be equal to the limit as h approaches 0 of where there is f of x plus h. You're going to substitute sine open brackets x plus h, then you subtract with the function itself, which is sin x, then you divide with h. Okay, so this is what we get. Now the next step is let's recall from trigonometric identities that let's remember that from trigonometric identities, given sine, then open brackets, you have two angles that are adding a plus b. What you simply obtain is sine of the first angle a to multiply with cos of the second angle b, then you say plus cos of the first angle a to multiply with sine of the second angle b. So this is the same concept that we're going to use on sine x plus h. So this will give us limit as h approaches 0. So this will be, why the sine x plus h, we're going to put sine first angle, which is x, according to the identity above, then cos of the second angle h. Okay, now be mindful that cos h is not a hyperbolic function, but instead just cos h, just representing some angle there. Then you say plus cos of the second angle, which is x, then sine h. Then you say minus, because this part was only covering sine x plus h only. Then you say minus, there, sine x, which is the remaining part from the step that we wrote on top there. Then like what we've been doing, divide everything by h. Okay, so this will continue by this will be limit as h approaches 0. Now if you look at the first part of this expression and the last part, they all have something in common, and that is sine x. So these can be grouped together. So we're going to group these together. So this will therefore be sine x cos h, then there will say minus sine x, then we add with the remaining one, which is plus cos x sine h, then divided by h. Okay, so what we now obtain is limit. So you can simply put this under parentheses. So this will now be limit as h approaches 0. So we're going to factorize the sine x. So sine x factorized will simply give us we'll write sin x, then we write our parentheses. We're going to have, then we remain with cos h, then minus, the last part will just be a 1 since it's sin x which has been factored out. Then we say plus cos x times sin h, like what we've been doing, divide everything by h. Okay, then we continue by saying limit as h approaches 0. So I can put brackets there and simply split the h there. So first part we have is on a, so I'm going to have sin x open brackets cos h minus 1 over h, then plus cos x sin h over h, then we'll close. Okay, so now we're going to use the rule of limits, which is the addition rule. We're going to distribute the limit with what is inside there. Okay, so we're going to have limit as h approaches 0 of the first part, which is sin x open brackets cos h minus 1 over h, then we write limit as h approaches 0 of cos x, then sin h divided by h. Okay, so here we can continue this by simply saying limit. So since multiplication is commutative, we can write the sin x first, then cos h minus 1 to be the one to divide with h. So we do the same with the second part also. Say cos x multiplied by sin h over h. Now there, what we do next is we're not going to use the multiplication rule for limits. So we say limit, the first part, which is sin x, will have the limit on its own, so to be limit as h approaches 0 of sin x, to simply multiply with limit as h approaches 0 of cos h minus 1 over h, then you say plus limit as h approaches 0 of the second part, first part, which is cos x, then times limit as h approaches 0 of sin h, then this is divided by h. Okay, now from there what we do next is we're going to say limit as h approaches 0 of sin x. Since sin has no h in it, so it therefore means that this will just be sin x. This is from the rules of the same limits, so this just give us sin x. So we're going to get sin x there, then we say multiply by limit as h approaches 0 of cos h minus 1 over h, then you say plus, so same applies here. Oh sorry, here is not supposed to be h but rather x, so this one here is x, so this will be limit as h approaches 0 of cos x, just be cos x, because cos x there's no h in it, so this will be cos x, then to multiply with limit as h approaches 0 of sin h over h. Now also one thing that we need to recall from limits is that the two parts cos h minus 1 over h and sin h over h, so limit as h approaches 0 of the first part, which is cos h minus 1 over h, this one is giving us a 0, and also the second part, which is limit as h approaches 0 of sin h over h, this one gives us a 1. So we're going to record the video on these two to prove why the first one is 0 and the second one is 1. Now let's do our substitution. So we're going to have sine x there to multiply with that which is equals to 0. So we're going to have that part is equal to 0, then plus cos x, which will multiply with that one, which is 1. So times 0, then plus cos x to simply multiply with the other one, which is a 1. So that one will go because it will be a 0, then we're remaining with cos x. So this is our answer.